Welcome to Sravz Technical Series. In today's session, we will discuss Airflow Dask and AWS S3 Parquet file use case. So in the previous session, if you recall, we did a CPP AWS S3 select. So I can go back to that page from the index page. So we did discuss AWS S3 client service S3 select operation through AWS S3 select. We were selecting data on the Parquet file and displayed that on the browser. So I'll do a quick demo of that code base once again as a quick recap. So I have this Boost REST API server running right now here. Then when I send a request, I'll get the data in this format. So for Sravz ID, for example, Google in this case, I have start date of around 10 years back. At Sravz, we limit the data request to 10 years. So for past 10 years, these are the summary statistics. The annual return was around 16%. Cumulative returns last 10 years was 315%. Annual volatility 28%, etc. So we have a bunch of other ratios. So we'll discuss these ratios at the later point, but for now, we just want to discuss how we are generating this data. And then we also have a bunch of statistics like in last 10 years, we had total count of around 2293 days of trade. So that many observations we have, and these are mean, standard deviation, min. So the max return for a single day was around 16%. On some day it gave 16%. And the worst was around 11%. On some day it fell 11%. So this is just for Google. Similarly, we have for AMD, EXTR is some other symbol. So I picked it up randomly. So we generate this data in a Parquet file, which is shown here, right? Code stats underscore Parquet file. Right now it has around 5,000 tickers in that Parquet file. And then using AWS S3 select, we are getting the data of few symbols, which we are interested in. So this is to prevent the browser from being overloaded. Right now, this Parquet file is around 1 MB. So we cannot send the whole 1 MB file to the browser and do the filtering on the client side. That's too much data. So that's why we use AWS S3 select to limit what data is needed on the browser and send it through. So that is the demo we did in the previous session. In today's session, we'll discuss how we generated this massive 1 MB, around 5,000 tickers statistics. So I'll quickly switch to the browser. So I put today's session as optional in C++ section. If you're interested, you can go through it or you can skip it if you are just focused on C++. So this session is mostly about Airflow and Dask. So I have that session here. So this is today's session. So I'll just summarize it again, what we are doing today. We're going to use Airflow, Dask to generate summary statistics of individual ticker of around 5,000 tickers. So we have used tickers from S&P 500, NASDAQ 100, Wilshire 5000, Russell 2000, Russell 3000. We took all the stickers and made the unique list of those stickers, and we are generating the statistics of those stickers. So the way the process works is we use the Airflow to schedule this to run every night on the weekdays and on Saturday, because you'll get the data for Friday on Saturday. So every weekdays and Saturday, you trigger the DAG. The Airflow DAG will be picked up by one of the Celery workers, and the Celery workers will gather all those 5,000 tickers and push a bunch of function calls to Dask cluster. The Dask cluster will take individual ticker and then will schedule the work on individual DAG workers. So each DAG worker will get a bunch of tickers it has to process. So then once the Dask worker gets the summary statistics of individual ticker, that ticker, data, individual ticker data is pushed to AWS S3 or Contabo, whichever is a S3 compatible service. Then once all the work is done, Dask will let the Airflow worker know that all the function calls are complete. Then the Airflow worker will go through individual data frame statistics in AWS S3, combines them all, creates one huge data frame, a unified data frame of all the individual summary statistics, converts that data frame into a Parquet file, and then pushes the Parquet file to AWS S3. So that's the summary in short I have written here. So we'll go through a quick demo. I have the Airflow up here. This is one of our clusters, Airflow. So I triggered the DAG, so it is running. If you see here, the last 2 days the DAG was successful. So the DAG takes around 4 hours to complete because there are 5,000 tickers, and each ticker has so much, it has to process the ticker, generate the statistics and all. It's a lot of CPU intensive work into 5,000 because there are 5,000 tickers. So I just triggered the DAG here. To trigger the DAG, you click on this button, then it starts. Then once the DAG starts, it pushes the data to the Dask cluster. So if you look here, so the Dask cluster is processing around 5,249 tickers. So we have around, so if I go to the worker node, and then we'll squish this. So we have around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Dask worker nodes. So 10 Dask worker nodes are processing the 5,000 tickers. So we have all of them running in parallel, and individual worker node is processing them, the tickers. So now if you look at it, it's quite fast. There are around 1900 tickers left to be processed. So it's quite fast. So it might complete in next 5 or 10 minutes. So while it runs, we'll go back to the browser and go to the source code. So as I mentioned, and I showed in the demo, this is the summary statistics of individual ticker we are generating. For example, for Google, we generate these summary statistics. So we'll go through these individual statistics later, and we use these for automated trading. Similarly, we have the output for EXTR symbol, AMD. So AMD returned around 37% annually and around 2,306% cumulatively over last 10 years. So that's a decent return. So this is the code for the DAG. The DAG Sravz code summary stats, which I just showed you. Sravz code summary stats, which is running in Airflow. It uses a bash operator. The bash operator runs a Python script. So, and the rest is basic for Airflow DAG. If you're interested in more details of the Airflow DAG, please let me know. I'll create more videos on that. Then we'll go through the summary_stats.py file. This is the summary_stats.py file. So this is the main function we call get summary stats. Get summary stats function will take bunch of tickers. If we don't pass any tickers, we'll get the tickers from our database. So as I mentioned, we get the tickers of S&P 500, NASDAQ 100, Russell 2000, Russell 3000, Wilshire 5000. That's around 5000 plus tickers. Once we get all the tickers, we create a set of those tickers to form a unique list. Then convert the set to list to get the unique set of tickers. Then we create a client using Dask hostname and the port. This is the Dask client name. And then to the Dask client, we send an array of tickers. So this is more like a map reduce. So for we're passing get_stats def function to the client with the list of tickers. So we'll go through that functions. We can go through it now. So get_stats df function will take a ticker. Ticker will get these libraries will go through later. For now, we'll just focus on how we are getting the data frame. So inside this PCA engine, we get the percentage daily returns for S&P 500, and then the stock returns for individual ticker. And then we using another library, which is a PyFolio library. We get the performance statistics of individual stock, which is in a data frame. Then we convert the data frame into a dictionary. Then we'll add the collection name, and then we pass the data frame as a dictionary to the upload codes to countable, a separate function. So we won't go to these function now, but at a high level, we are getting the performance statistics using PyFolio library, and then we upload this to Contabo or AWS S3. So we do that per ticker. So once the data for individual ticker is pushed to Contabo or AWS S3, and all the client returns here at line 61, which is a blocking call, which is right now still going on. So yeah, there's still 134 tickers to go, 114. So right now the client is gathering all the return values from Dask. So it's super fast. Once it completes, the Airflow data frame, Airflow DAG should complete. So all the work is completed. We have processed 5,249 tickers. So this one should complete anytime soon. So now Airflow is gathering all those individual data frames. So this has completed. So now Airflow is gathering all the data frames into a single data frame. It will get individual ticker stats from Contabo, creates using PD. It will append the data frame to the list, and then using PD concat all the data frames into a single data frame. Then we do some manipulation of column names so that the column names are more JSON friendly. So we remove spaces and put underscore, remove percentage symbol and put PCT, etc. Lowercase all the column names. Once we do all that to the data frame, we upload the final single data frame to the AWS S3 using upload code stats to AWS. In the upload code stats to AWS, we get a path where the Parquet file should go. In this case, code stats.parquet file. And then using AWS Data Wrangler, we convert the data frame to a Parquet file and push it to AWS S3. All of that conversion and pushing to S3 taken care by Data Wrangler. So it's much user-friendly, easier library to use. So with that, we have the Parquet file in the AWS S3. So I won't open AWS S3 to save time, but I got a screenshot here. So this is how the Parquet file would look like in the S3 console, AWS S3 console. It's around 1 MB for 5,000 tickers. At a future time, we'll add more tickers to it, like ETFs, futures, mutual funds, etc. So let's see, the Dask is completed. Airflow is still processing that to a single data frame, so it will eventually push it to AWS S3. So with that, I'll conclude this session. If you have any questions, please reach out through the YouTube channel, or you can ask your questions here, and I'll answer them accordingly. Thank you for watching.